Second Adventures in Astronomy, number 5, The Rotating Moon. Whenever you look at the moon from Earth, it always looks similar. Different parts are illuminated at different times, but oddly we always see the same features. The moon never turns its back on us, much like the rules of etiquette when you visit the Queen. So does this mean the moon doesn't rotate? Well, no, because then, as it orbited us, we would see first its front, then its left side, and then its rear.
If you build a sandcastle on the seashore, a few hours later it might be completely underwater. Let's dive into why. When we talk about the tide changing, we are referring to the rising and falling of the surfaces of the ocean and other large bodies of water. The tide rises and falls twice a day, shifting roughly every 6 hours in either a flood tide or an ebb tide. This happens because Earth has tidal bulges on opposite ends, where different parts of the ocean stretch outward as Earth rotates. The strongest force causing this is the gravitational pull from Earth's moon. Yes, even stronger than the gravitational pull of our enormous sun, because the moon is closer to Earth. The closer two objects are together, the stronger the gravitational pull between them. The same reasoning explains why Earth's tidal bulges occur where they do. The moon is like a magnet, pulling Earth and its water bodies toward it. The water at the point closest to the moon is pulled more strongly toward it, creating a bulge in the direction of the moon. Earth's body is pulled a little less because it's slightly further away from the moon. Finally, the water on the side farthest from the moon is being pulled the least, creating another bulge by lagging behind Earth. This follows the concept of inertia. Any object at rest will resist moving. Hence, the far side bulge is created as the water over there isn't being forced to move toward the moon as hard. When areas of the ocean bulge out, the tide rises. When Earth rotates, their position changes. They no longer bulge, and the tide falls. So if you're thinking about how the moon affects the tides, it might be helpful to imagine its force trying to stretch the soccer ball-shaped Earth to look more like a football.